Page 5, here we go. Let's dive in. Graph the following inequalities. So I'm looking at inequalities. They're going to be there's going to be shading. I'm going to have to decide on dash and solid lines, all that good stuff. So let's look at 13. Notice the form, slope-intercept form. Similar to our in page 2 of our review where we talked about how to graph in slope-intercept form. You start at the y-intercept, which is -7. Let's count down 1, 2, 3, 4, 5, 6. -7. That'll be 1 point. And then from there, the slope tells you what the line is going to look like. If I have a slope of 2, it's the same thing as saying I have a slope of up 2 over 1. Up 2 over 1. Up 2 over 1. So my line, and these are the things you got to remember. I have a less than sign, so my line has to be dashed. The last thing I got to decide is which side to shade on. So I want to pick a test point of 0, 0. If it is a solution, if it's a yes, I'm going to shade on that side. If it's a no, then I'm going to shade on the other side. So let me plug in 0, 0. 0 greater than 2 times 0 minus 7. Basically, I get 0 is less than 2 times 0 is 0. Minus 7 is -7. My question is 0 less than -7? No, it's not. So since it's a no, I'm going to shade on the other side of the line. Which makes sense if you remember from last page. Slope-intercept form, when it's a less than sign, I'm going to shade below the line. 14. Couple issues when you're graphing this line. It kind of looks different because there's nothing out here. It's like, well, okay, if there's nothing out here, we can put a +0. That makes you feel better. Might help you see that 0 is the y-intercept. Slope is still right in front of the x there. It's -4. 1, 2, 3, 4, down 4 over 1. 1, 2, 3, 4, down 4 over 1. The line is solid because my symbol had the line underneath it. Okay. My last decision that I have to make is, what side do I shade on? Normally I would pick 0, 0 as my test point. Well, that's not possible because the line goes through it. I have to pick a different point. I'm going to pick 1, 1 as my test point. I can pick any point that I want, and I want to keep it easy. So I plug in 1 for x and 1 for y. 1 greater than or equal to -4 times 1. And my question becomes, is 1 greater than -4? Well, yes, by golly, it is. Yes. So I'm going to shade on the side with the test point. Any point on this side, any point that I choose, it would work for this inequality. Any point that I choose over here would not work. Let's move on. 15. Standard form. You need to refer back to page 3. We talked about standard form. AX plus BY equals C. It's all about finding the intercepts. So if I want to graph the line, let's do x-intercept in red, y-intercept in blue. X-intercept is going to have a y value of 0. There we go. Talking about x-intercept. So x-intercept is when I plug in 0 for y. Now, we talked about how that basically means the y value is going to go away. Get 6x less than or equal to 20. Oh no, it's going to be a fraction. It's okay. You get x is less than or equal to 3 1/3. So I know I have a y-intercept, or excuse me, x-intercept of 3 and a little bit more. Oh, right there. Okay. My y-intercepts, I know it's going to have an x value of 0. So I plug in 0 for x. Forget that negative sign there. Your x values go away, but there still is that negative 4y. So you get divided by negative 4, y. Now, this is kind of a random thing that happened, but you divided by a negative, so it flips the sign. It's not going to have a huge effect on our problem. Y-intercept of 1, 2, 3, 4, 5. Decide if you're dealing with a solid or a dashed line. Looks like I'm dealing with a solid line because there's the line underneath. My last decision. Sorry, your y-intercept is negative 5. X-intercept is 3 1/3. This is what side to shade on. Use a test point, 0, 0. I'm plugging in, let's see, 6 times 0 minus 4 times 0 less than or equal to 20. Okay, well, that's going to go to 0. Minus, that's going to go to 0. So the question is 0 less than or equal to 20? Let me write that again. Is 0 less than or equal to 20? Oh my goodness, booger. The junk. I'm going to write it down here. Is 0 less than or equal to 20? That's the question. Yes! That means my test point is true. It means all points on this side of the line are also true. Last problem. 16. Standard form. How about finding intercepts? X-intercept, Y-intercept. X-intercept is where I have a 0 y value. 4x minus 7 times 0 less than negative 28. When something's multiplied by 0, it goes away. 4x less than negative 28. So I get x-intercept of negative 7. 1, 2, 3, 4, 5, 6, 7. There. And here the inequality doesn't matter as much because right now I'm just graphing the line. What the inequality is going to tell me is whether it's dashed or what side I'm shading on. But right now I'm just finding the intercept, so the x is less than negative 7 doesn't mean as much. It's more that I just found the intercept. The y-intercept is where I have a x value of 0, and I plug in 0 for x. Anything multiplied by 0 goes away. Negative 7y less than negative 28 divided by negative 7. Y, again, I divided by a negative, so I flip the sign. Negative divided by a negative is positive 4. So I have a y-intercept of 1, 2, 3, 4. As a point at 0, 4. The x-intercept was negative 7, 0. Once you have 2 points, you have your line. So that's great. I got to decide if it's dashed or solid. It is dashed. And my last question is, what side do I shade on? I'm going to test 0, 0. Testing a point just means I'm plugging it in. 0, 0, plugged in for x and y. 4 times 0 is 0. 7 times 0 is 0. So the question becomes, is 0 less than negative 28? Hex no. So I'm going to shade on the other side of the inequality, of the line. Which makes sense. If you look at it, y is greater than 4. Well, yeah, my y value bigger than 4. X is less than negative 7. Yep, that makes sense. It's going to x less than negative 7. There you have it, page 5, sorry.